When you go to sit in a chair, have you ever wondered why your seat is cold at first but gets warm after a while? This is due to the Chatelier's principle, which states if a chemical reaction is not at equilibrium and experiences a change in pressure, temperature, or concentration of products or reactants, the equilibrium will shift in the opposite direction to offset the change. Here I have iron 3 nitrate in a test tube, and I will add 2 drops of potassium thiocyanate. By adding potassium thiocyanate, I'm shifting my equation to the right to make more product, which is why it makes a darker red color. By adding sodium phosphate, iron 3 plus ions will participate out of the solution, making iron phosphate. This reduces the concentration of iron 3 plus ions in the solution, which causes the reaction to shift left and make a lighter yellow color. Finally, to make the reaction shift back to right, I will add iron 3 chloride, causing a higher concentration of iron 3 plus ions. Since I have more reactant of iron 3 plus ions, this will help the solution make more product and reestablish equilibrium. To produce more product, I am adding potassium thiocyanate to further the shift of the equilibrium to the right. Due to the increase in the concentration of the product, the pigment of the color red darkened than was originally from before when we added the iron 3 chloride. At the bottom of the test tube is the iron 3 phosphate, which precipitated out from adding sodium phosphate and being insoluble in the solution. In conclusion, we have demonstrated Le Chatelier's principle by disturbing the products and reactants concentration and viewed how the position of the equilibrium shifts to counteract the change to reestablish an equilibrium. Also, we proved that equilibrium is just another word for balance, and the way to achieve balance is to adjust to the change and not stop the reaction. Remember, chemical reaction can be affected by not just changes in concentration, but also temperature changes through the favoring of exothermic and endothermic reaction, and also the reaction's pressure. Now you can see why your chair changes temperature when you sit in it. Thank you, and I hope to see you again.